Okay, everyone, here we go. We're going to start with lesson 4.4, and today we are going to be learning about scientific notation. Now, scientific notation is a way that we can express really large and very small numbers, and we will also look at comparing numbers that are written in scientific notation. So, scientific notation is a kind of shorthand that can be used to write large numbers. Now don't forget, this can also be used to write very, very small numbers, so you should add that in. A shorthand to write very large and very small numbers. Now any number that is expressed in scientific notation, they are written as a product of two factors. So the first example we have is 17,900,000, and we're writing it as a product of two factors. The two factors are 1.79, and the second one is 10 to the 7th power. Now your first factor must always be a number greater than or equal to 1, but less than 10, and your second factor is always going to be a power of 10. And please note that whenever we are working with scientific notation, you will use the cross instead of the dot in our multiplication. So we have two very extreme numbers here. An ordinary quarter contains about, whoa, that number is way too big. I have no clue how to read that. And then if we look at the average size of an atom, at how many centimeters across it is, that's very, very small. I don't really know how to read that either. So what we do is we convert these numbers into scientific notation to simplify them to make it easier for us to read. So the ordinary quarter contains 9.77 times 10 to the 22nd power atoms, and each of those atoms is 3 times 10 to the negative 8th centimeters across. Now a helpful hint, a positive exponent means we are moving the decimal point to the right, and a negative exponent means that we will move the decimal point to the left. Those are two important points. Make sure you are writing them down because that's going to help you when we are converting our numbers from scientific notation back into standard form. Okay, let's go ahead and move on. And what we have first is changing these numbers into standard form. Excuse me. Our first number, 1 and 35/100 times 10 to the 5th power. Again, we look to the exponent. The exponent is a 5. That 5 tells us how many places to move the decimal point, and because it's a positive 5, you are going to move to the right. So I start with the decimal number that is given in the problem, 1.35, and now I need to move that decimal point to the right 5 places. 1, 2, 3, 4, and 5 places. We want to make sure we fill in with zeros, and then I do want you to rewrite your answer in its final form, 135,000. Our second example, I have 2.7 times 10 to the negative 3rd. Notice the exponent is a negative 3. This time we're going to move to the left with our decimal point. So 2.7. And let's move that decimal to the left 3 places. 1, 2, and 3. Place your decimal point and fill in, I'm going to call those waves. Fill in the waves with zeros. And 2.7 times 10 to the negative 3rd would be 27 10,000ths. So we just changed scientific notation back into standard form. Go ahead and try these two. Pause your video and then turn back on to see if you get the right answer. The exponent is 8. Move it 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. Fill in with zeros. Rewrite your answer. And don't forget to put the commas in for an answer of 509 million. And 1.9 times 10 to the negative fifth, the exponent is negative 5. Move your decimal to the left 5 places, 3, 4, and 5. Fill in with zeros. And our answer, 1, 2, 3, 4 zeros, and then 19. Great. Now let's do it in the opposite direction. I'm going to give you a number in standard form. You are now going to turn it into scientific notation. Remember the rule for scientific notation. The first factor must be a number greater than or equal to 1, but less than 10. So we always move our decimal point behind the first non-zero digit. And in this case, that first non-zero digit is the 7. So now I'm going to write my first factor. My first factor is 7 and 9/100. So I must write that 7 and everything that comes behind it. Now remember, we want to multiply by a power of 10. So I'm going to put my base 10 in. And now let's go back to the smile that I made. I like to call that the smile. When we moved our decimal point, we made a smile. Consider the numbers inside that smile teeth. Knock out the teeth. How many numbers are within that smile? 1, 2, and 3. There are 3 numbers in that smile, and so that's our exponent. Now notice, this number is the standard notation. The original form of this number is less than 1. So that means our exponent must be a negative. I'm going to rewrite that answer because it's difficult to see. 7 and 9/100 times 10 to the negative third. Whenever you start with a number less than 1, your exponent is going to be a negative. Let's try our next one. Again, we're going to move our decimal point, make a smile, put that decimal behind the very first non-zero digit, and write your first factor, 8 and 11/100. You know you are multiplying by a power of 10, and you should also know that that is a negative exponent because the number we started with is less than 1. Now go back and count how many teeth are inside the smile, or how many numbers are inside the giant swoop. 1, 2, 3, 4. And there's our final answer. 8 and 11/100 times 10 to the negative fourth power. Okay, now we have a number that is greater than 1. So now that our number is greater than 1, we are going to have a positive exponent. Remember, all whole numbers have a decimal point located at the back of the number, and our first factor must be a number greater than or equal to 1, but less than 10. This decimal must be placed behind the very first digit given in the problem. Our first factor is 4 and 34/100. We are writing it in scientific notation. That means I need a power of 10. And again, let's count the teeth. How many numbers are inside our giant smile? 1, 2, 3, 4, 5, and 6. And there's our exponent. Final answer, 4 34/100 times 10 to the 6th power. Go ahead and try the next one. Pause the video, come back and check your answer. Move your decimal point behind the very first given digit. Write your first factor. Remember, the factor must be greater than or equal to 1, but less than 10. So my first factor is 8.421, or 8 and 421 thousandths, times 10, and again count your digits inside the smile, to the 6th power. Okay, let's compare. A pencil is 18.7 centimeters long. If you were to lay 10,000 pencils end to end, how many millimeters, millimeters long would they be? We need to write our answer in scientific notation. All right, so notice that the pencil is 18 7/10 centimeters long, and we are going to take 10,000 of them and lay them end to end. And we want to know how many millimeters long that would be. First thing we are going to do is start by multiplying 18 7/10 times 10,000. Now notice, I'm going to offset these zeros, and when we offset zeros, we just bring them down, and now when I multiply by 1, okay, how many digits come after the decimal point? We have only 1, so I need to move my decimal point 1 place. And now that is 187,000 centimeters. 187,000 centimeters. Now, remember what your science teacher taught you. King Henry died drinking chocolate milk. Or, I think the Cordos use, Cordo helps Dairy Queen make chocolate malts. Something like that. Centimeters to kilometers, you're going to move your, centimeters to millimeters, you're going to move your decimal point 1 place to the right. So our final answer, you have to move that decimal 1 place to the right, that would be 1,870,000 millimeters. Oh, but wait, they want us to write our final answer in scientific notation. All right, one more step in solving this problem. Big smile. Knock out the teeth. 1, 2, 3, 4. Whoops, sorry about that. 5 and 6 millimeters. Final answer in scientific notation. Okay, we have a certain cell has a diameter of approximately 4.11 times 10 to the negative 5th meters. A second cell has a diameter of 1 5/10 times 10 to the negative 5th meters. Which cell has a greater diameter? Well, what's great about this question? Both of the powers are exactly the same. They both have times 10 to the negative 5th power. So what we can do whenever we want to compare, as long as the powers are exactly the same, ignore them. And now look at your two decimals. Which number is greater? And I'm hoping you're going to tell me that that is 4 11/100. At this point in time, I would like for you to try questions 1 through 10 on page 176. Don't worry, we will do lots of practice tomorrow with scientific notation, and knowing me, I probably have a foldable for that. Have a great evening, everyone, and I'll see you tomorrow.